Hello friends, welcome to my YouTube channel Aviator Updates. If you don't know me, I'm Rakesh Negi and I'm an aviation enthusiast. In today's session, we are going to discuss about GRAD corrections. Okay, so we'll be discussing what is a GRAD correction, why do we apply GRAD correction, where do you find the GRAD correction, and how do you apply the GRAD correction. Okay, so GRAD corrections. So for GRAD corrections, we have two types. One is GRAD 1 correction and the other one is GRAD 2 correction. Okay, so we have GRAD 1 and GRAD 2 corrections. Now, what are these corrections? These corrections are basically the gradient corrections which are applied to the weight based on the temperature or the actual temperature. Now, in order to understand this, let us go in a bit more depth. So where do you find these corrections, GRAD 1 and GRAD 2 correction? So these corrections, you can find them on the RTOW chart at the bottom of a particular column. Okay, let's suppose we are considering the Chennai airport. Okay, runway 25. Okay, where the headwind is suppose 10 knots, and let's suppose we are considering config 1 plus F. Okay, with OAT of 26 degrees Celsius. Okay, so this is the OAT. Let us consider these conditions in order to understand our topic, which is GRAD corrections. Okay, so this is the RTW chart of Chennai for runway 25, runway dry, and config 1 plus F and config 3 are given here. We are in our example, we are just considering config 1 plus F and headwind as 10 knots, so we have to prefer this column for the purpose of calculation. This is the topmost box as well in this column. So as you can see in this column, the temperature here is 57, 56 here, 55, 53, 52, and the lowest here in this is 46 degrees Celsius. So 46 degrees Celsius is the lowest temperature, which I am calling as BT, that is a box temperature in our explanation. Okay, so this 46 degrees Celsius, which is the lowest temperature, corresponds to the highest weight in this chart, which is 81. Okay, so this is the weight entry, which I am calling it as weight entry, 81 tons, and delta weight is 0.4. So this, sorry, not 0.4, and delta weight is 0.1. So 81 plus 0.1 tons makes 81.1 tons, which is your corrected MTOW, okay, or corrected weight. So now in this 81.1 tons, okay, which we see here, this is for box temperature of 46 or OAT of 46. So our today's OAT is not 46, it is 26 degrees Celsius. So now if you want to compute for 26 degrees Celsius, you have to extrapolate, you have to go beyond this box. Okay, so for 26 degrees Celsius, which will be beyond this box, okay, there will be a particular weight which will be obviously higher than 81 tons. So that's what we have to calculate in our example. So let's go ahead. So before we go ahead, also I would like to show for this column, if I go down like this, you can see the GRAD correction given here. Okay, so here is the GRAD 1 and GRAD 2 corrections, which is given in kg per Celsius. Okay, so in our example, the GRAD correction is 50/520, as you can see here, 50/520, this one. Okay, so 50 is GRAD 1 and 520 is GRAD 2. So this GRAD correction is for which column? 10 knots headwind column. For other columns, different values are given here, here, here. In some places they are not applicable. Here, as like here you can see only GRAD 1 is given, here GRAD 1 and GRAD 2. So every column will have its own GRAD 1, GRAD 2 correction values, okay, which if applicable will be given. In our example, it is this one. Okay, so that's the GRAD correction value, which you can see at the bottom of the column here. So this is the 10 knot headwind column. Okay, this one. So that's about the 10 knot headwind column. Okay, so our entire explanation is based on this column. Suppose this topmost box is empty. In some airport charts, if this is blank, then the GRAD corrections are not applicable. Okay, but here it's given, so it's applicable. Now TREF, where was it given? TREF is given here. Okay, TREF is 44 degrees Celsius for this airport. Okay, as we have discussed earlier in my previous video, that TREF is a function of pressure altitude. Okay, so that's why for Chennai airport it is given as 44 degrees Celsius in this chart. Okay, so let's continue with the explanation. So by the way, I'll prepare a separate video how to calculate the RTOW, that is the regulatory takeoff weight or maximum takeoff weight. Let us consider these conditions or parameters. Now in order to calculate the RTOW using these conditions, first in the RTOW chart, check the config 1 plus F section, okay, or columns related to it. In that, identify the winds which is relevant to you for that particular day. Okay, suppose in our case 10 knot headwinds are there. Okay, you have to identify or you have to calculate the wind which will be relevant to the one which is given on the RTOW chart. In our example, it is 10 knot headwind. Okay, now as per 10 knot headwind for config 1 plus F and OAT 26 degrees Celsius, we have to identify the MTOW, that is the maximum takeoff weight. So in the chart, okay, which you can see here in the Chennai chart, okay, 425, there is no box which is showing you a temperature of 26 degrees Celsius. Okay, and in the 10 knot headwind column, you can see that the box temperature is 46 degrees Celsius. So I'm writing here box temperature. It is also kind of OAT. It is 46 degrees Celsius. So this is the lowest temperature which is available on this chart. So if you see the chart from top to down, okay, you will see that the temperature is decreasing as you go upwards. So the topmost box is showing you the lowest temperature, and I am using which column? I am using the column which is for 10 knot headwind, which is showing you 46 degrees Celsius. That's why I've written it here. Okay, now for 46 degrees Celsius, the weight which corresponds to it is 81 tons. Okay, so the weight entry here is, weight is how much? 81 tons. Okay, and if you see the box, the delta weight which is given here, delta weight is 0.1. okay, in this chart. So delta weight is 0.1 ton, so this becomes 81.1 tons. Okay, so that means for 46 degrees Celsius temperature, the maximum weight which is possible as per this box is 81.1 tons. Okay, now this 81.1 ton is for 46 degrees Celsius, but today's OAT is not 46, it is 26 degrees Celsius. Now you have to find a weight which will correspond to 26 degrees Celsius. So in order to find that weight, okay, you have to go beyond this box. That means you have to extrapolate. Okay, so you have to extrapolate to find a particular weight which corresponds to 26 degrees Celsius. So as of now, you know that for 46 degrees Celsius, the weight is 81.1 tons. Okay, so how do you calculate the weight? So in here comes the role of correction, which is called as the GRAD correction. So in order to understand the concept of GRAD correction, always if possible try to draw this type of diagram. Okay, y-axis and x-axis. X-axis showing you the temperatures, okay, and y-axis showing you the weight. If we talk about basic physics, as the temperature increases, the air density is reducing, right? So as the air density is reducing with the increase in temperature, if density reduces, then the thrust reduces, and if the thrust reduces, the aircraft capability to carry higher weight also reduces. Okay, but if we talk the other way around, if suppose the temperature is reducing, so when temperature reduces, the air density obviously will increase. That means the number of molecules of air which will enter inside the engine will be more, okay, whenever you are running the engine. So in that case, the engine will have a higher capability to produce more thrust. That means the aircraft will have a capability to lift more weight. As the temperature decreases, the aircraft capability to carry weight also increases. Okay, so that's why there is a standard diagram here, okay, where you know that there is a temperature called as the T-ref or reference temperature, which we have studied earlier. This one. This is also called as flat rating temperature, as we discussed earlier. Up to flat rating temperature, what happens is, okay, the graph does not go straight like this because weight. Okay, before we have studied that there was thrust. So in case of thrust, the engine is flat rated. Okay, so below T-ref, the engines were producing flat rated thrust, which was constant. But weight is not straight. For weight, the graph will go slightly up like this. Okay, it is not straight. Just because we have studied about the basic physics where we interpreted that as temperature reduces, the aircraft capability to carry weight also increases. That's why the graph, instead of going straight, it goes slightly up. Okay, not too much slant, but slightly up. Okay, so this is what happens up to Tref. Below Tref, again it repeats the same, it decreases. Okay, because as the temperature is increasing, the thrust producing capability of the aircraft will reduce. So for the aircraft to lift that weight of the aircraft, it has to have certain thrust, but that thrust will reduce because the temperature is increasing. Okay, that's why the graph goes down like this. Okay, now here, how do you apply the corrections? So we have seen that whenever you are in the process of computing the RTOW or MTOW, first you calculate a particular weight, which you can call it as the corrected weight, which is 81.1 tons in our example. Is this the final weight for us as per the topic which you are considering? No. Okay, so in this you have to apply some correction. Why should you apply correction? Because this weight is for 46 degrees Celsius. So you have to calculate the weight for 26 degrees Celsius. So now, in order to calculate the weight, you have to extrapolate. That means you have to go beyond this box. Okay, so the topmost box here is showing you 46 degrees Celsius. Okay, so if you go beyond this box, then only you can extrapolate for a particular weight, and that weight will be higher than 81.1 tons, right? So let us find out that. So in order to find out that, you have to apply GRAD corrections. So to apply GRAD corrections, draw this type of graph first, and then here you can say this is for GRAD 1. Okay, so below Tref you apply GRAD 1, and above Tref what applies is GRAD 2. Okay, so this is what you have to remember. Okay, suppose your OAT is 26, which we have studied. Okay, so suppose the OAT is 26 here, 26 degrees Celsius is your OAT. Tref, where do you find? You can find on the RTOW chart. So on this RTOW chart, the Tref given over here is 44 degrees Celsius. So I'll write here 44 degrees Celsius. Okay, so that's our Tref. And what is the box temperature in this example? So box temperature which we are considering is the lowest temperature on this chart. So in the appropriate wind column, which is for 10 knots, which is here, okay, if I see this column, the lowest temperature here is 46 degrees. So I'll write here 46. At this point, we have the box temperature, which is the lowest temperature on the chart, which corresponds to the highest weight. Okay, lowest temperature, that is the topmost box, will obviously correspond to the highest weight on this chart. Okay, so 46 degrees Celsius is the lowest temperature. Okay, 46 degrees Celsius. So we have 26 degrees Celsius, 44 degrees Celsius, and 46 degrees Celsius. So GRAD 1 correction, it is applied below Tref, and GRAD 2 correction is applied above Tref. Okay, so as of now we have discussed that the OAT is 26, box temperature which you find on the chart, which is on the topmost row of the RTOW chart, is the lowest temperature is 46, and Tref you get from the bottom of the chart, which is 44 degrees Celsius. Okay, so I hope this much is clear till now. Now let us understand where do you find the GRAD corrections, as like you can see on this chart. Okay, so on this chart you have to prefer which column now? 10 knot headwind column for config 1 plus F. So this side is config 1 plus F, this is config 3. So for config 1 plus F, for 10 knot headwind column, I'll go down like this, and here at this bottom I can see GRAD 1 and GRAD 2 correction given in kg per degree Celsius. Okay, so the GRAD corrections for this column is here, for another column it will be here, and so every column at its bottom will have a GRAD correction, okay, if available. At this bottom, what is written here is, I'll just read out for you as it is not visible to you. It's 50/520. Okay, so they have given GRAD 1/GRAD 2. Okay, so for GRAD 1/GRAD 2 they have given 50/520. This is what is written at the bottom of this 10 knot headwind column. Okay, this is your gradient correction, that is a GRAD 1 correction, this is GRAD 2 correction. So how do you apply? So in order to apply this, okay, let us see the calculation here. So how much was our corrected weight? Our corrected weight which we got for 46 degrees Celsius was 81.1 tons. 81.1 tons. Okay, so let's write in kgs. It will be 81,100 kgs. Right? Now in this you have to apply grad corrections. So now in order to apply grad corrections, there are three cases, okay, or three ways to apply the grad corrections. So in this example which you are considering, you have to apply grad 1 as well as grad 2 correction. Why? Because there is a reason which I will tell you after some time. Sometimes you have to apply only grad 1 and grad 2 would not be applicable, and sometimes only grad 2 you have to apply. In that case grad 1 will not be applicable. So in this example we have to apply both the corrections. Why? Because I told you there are three cases. Okay, so the first case is if the OAT is less than Tref and the lowest temperature is greater than Tref, you have to apply both the corrections. Okay, so what is the first case? I am writing here, first case, if OAT is less than Tref, okay, and the lowest temperature, which I am calling it as box temperature, okay, BT, and the lowest temperature on the chart or that particular column, okay, which we are considering here, at a 10 knot headwind column, and the lowest temperature in that column, okay, is greater than Tref. Okay, so this is case number 1. So in this case you have to apply grad 1 and grad 2 both. Okay, so both corrections will be applicable in this scenario, which is in this case. Second case, if both OAT and lowest temperature are below Tref, okay, if OAT and the lowest temperature on the chart, okay, in that particular column, like in the example it is 10 knot headwind column. So if the OAT and the lowest temperature, which I am calling it as box temperature, if it is less than Tref, then only grad 1 correction is applicable. Okay, only grad 1 is applicable. And third case, if OAT and lowest temperature on the chart is greater than Tref, okay, that is a flat rating temperature, okay, then only grad 2 is applicable. Okay, so these are the three cases which you have to remember whenever you will be applying the grad corrections. So okay, so what is the first case? When OAT is less than Tref and box temperature is greater than Tref, okay, apply grad 1 and grad 2. How do you remember this? So just draw this graph, write Tref here. So Tref, we have a left side and right side. Assume Tref to be in the center, okay, just in order to make the concept clear. Okay, so Tref, so if OAT is on the left side of Tref and if the lowest temperature is on the right side of Tref, then you have to apply both, okay, grad 1 and grad 2. If both of them are on the left side, suppose OAT and box temperature, they are lesser than Tref, that means if both of them are on the left side, then only grad 1 is applicable. Okay, and if both of them are on the right side of Tref, then grad 2 is applicable. Okay, so let us understand first case where we have OAT less than Tref and lowest temperature greater than Tref. So in this case, if you want to apply grad correction, so remember that grad correction is applied on the weight. Why? Because we are extrapolating. Why we are extrapolating? Because the temperature over here is up to 46. Below 46 there is no temperature, because as you go down there is 46, 52, 53, 55, 56. The temperature is increasing as you are going down the column. But if you want to go up and calculate for 26 degrees Celsius a particular weight, that means you are extrapolating. Okay, so if you want to extrapolate for 26 degrees Celsius, that means you want to apply grad corrections. Okay, and grad corrections are graded corrections which are applied on the weight. Okay, that's why we are doing the extrapolation. So how do we apply the weight correction? So first we'll apply grad 1 correction. Okay, I'm writing here grad 1 correction. So grad 1 correction, first you have to find the difference between these two. Okay, why? Because in our example, out of these three cases, the first case is applicable, OAT less than Tref. How much it is less? You have to find the difference. So 44 minus 26, how much it becomes? 18. What is the correction you are applying? Grad 1. So grad 1, how much it is? 50. So 18 into 50. So 18 into 50, how much it comes? Okay, 900 kgs. Next is grad 2 correction. So like as you have applied grad 1 correction, same we have to apply grad 2 correction. So grad 2, how do you apply? So we have seen that grad 2 correction is also applicable as the lowest temperature is greater than T ref. So this is the T ref, which is 44, and the lowest temperature in the chart is 46, which we have written here. So difference between both of them you have to find out first. So difference between them is 46 minus 44. How much it becomes? 2. Okay. Now this difference, multiply it with the value for grad 2, which is given at the bottom of the column here. Okay, which is 520 here, 520 here. So I'm writing it here, 520. So how much it becomes? 200, 224, 10 kgs. Okay, so grad 1 is 900 kg, grad 2 is 1040 kg. So total, how much is the weight now? 81,100 kg plus 900 plus 1040. It comes out to be 040D8. So 83,040 kg. Okay, so this is how we apply the grad correction on the weight. This 83,040 kg corresponds to 26 degrees. So for this chart, the temperature is up to 46 degrees Celsius. Okay, so beyond this, okay, if you want to go, you have to extrapolate, and that's what we did. So for 26 degrees Celsius, which will obviously be out of this box. So for 26 degrees Celsius, 8, which would be corresponding to it, would be 83,040 kgs. Okay, so this is how we have applied the grad correction. Let us take the other two cases also. If suppose your OAT and box temperature are less than T ref. Okay, consider another example. Suppose this one graph. Okay, to understand case number 2. Suppose your T ref is 44 only, your OAT is 26. Okay, and your lowest temperature on this comes out to be suppose 41. Okay, so 41 degrees Celsius is your box temperature, which is the lowest temperature. This is the T ref, for that is 44 degrees Celsius, and 26 is your OAT, and this is your weight, and this is your temperature. Same graph. So in this case, this is the T ref. So let's draw a straight line up like this, like this, like this. So in this case, only grad 1 is applicable. Okay, so how do you apply grad 1? So for grad 1, you have to find out the difference between the lowest temperature and OAT. Okay, so how much it is? 26 and 41. What is the difference between them? 41 minus 26, it becomes 15. Okay, so this is the difference between these two. So this is your grad 1 correction. Okay, so grad 1, it will be given at the bottom of the chart. So this difference you have to multiply with the value which will be given at the bottom of the chart. So in our previous example, it was 50. Suppose I'm considering the grad 1 value given at the bottom to be 50. Okay, so this grad 1 correction will be how much? 15 5s are 75, 750. Okay, so these are grad 1 correction. So only grad 1 correction is applicable in this case. This is case number 2. Case number 1 we have already discussed in this example. Case number 3, let's discuss here, which is this one. If OAT and box temperature are greater than T ref. Okay, our T ref is 44. So I'll just draw a line here. Our T ref, how much it is? 44. Okay, this is your T ref. Suppose your box temperature is 46. Okay, and your OAT is suppose 48. Okay, so just extend this line again here. This is a T ref, the standard graph. Okay, which is between weight and the temperature. So this graph goes like this. So in this case, grad 2 correction will be here, grad 2. So what? How do you calculate grad 2 correction in this case? Which case? If OAT, okay, if OAT and lowest temperature, which is the box temperature on the chart, is greater than T ref. So in this case, you have to calculate the difference between OAT and the lowest temperature. Mark it, OAT and the lowest temperature, as you did in this case. Okay, so what is the difference between OAT and the lowest temperature? Okay, it is 48 here and 46 here. Box temperature is 46, OAT is 48. So how much it becomes? 48 minus 46. So grad 2 correction is equal to 48 minus 46 is 2. Okay, so you have to find out the difference. After finding the difference, you multiply it with the grad 2 correction value. Where do you find? At the bottom of this chart. Okay, so at the bottom of the chart, suppose the value written is 520. So just multiply 2 with 520. How much you get? 5 2s are 10, 5 5 25, 26, 2600 kg. So this is the grad 2 correction. So in this case, grad 1 correction was not applicable. Why? Because the OAT and box temperature are greater than TREF. Okay, and in this case only grad 1 correction was applicable. Why? And grad 2 was not applicable. Why? Because OAT and box temperature were below TREF, and in this case both the corrections are applicable. Okay, so this is how you apply the grad correction. One important point, friends, grad correction is not applicable if the topmost box in the chart is empty. Okay, sometimes you may find a chart where the topmost box is empty. In that case, grad correction will not be applicable. Okay, so let us quickly summarize what we have learned today. We have learned that whenever you are calculating the RTOW or MTOW, there will be one of the correction which may be applied in some cases. Okay, and that correction is grad correction. There are some more corrections which we have not discussed today, is because we are not learning the entire process of calculating the RTOW. We are just trying to learn how do you apply the grad correction, which is one of the corrections which is applied on the RTOW or MTOW calculation process. Okay, so in order to understand that, we have taken an example. We have taken this chart. So we are considering Chennai Airport, runway 25. This Chennai Airport, runway 25. Okay, and 10 knot headwind column, config 1 plus F we are considering, and OAT is 26 degrees Celsius. So whatever calculation we have done for config 1 plus F, you have to do it for config 3 also, and then you calculate which one is optimum. Okay, about that we'll learn later in my another session. So let us just consider config 1 plus F over here. Okay, so and 10 knot headwind column. So here topmost box is showing you the 46 degrees Celsius, which is the lowest temperature. So on an RTOW chart, we'll always find that the lowest temperature is on the topmost box. Okay, so here the topmost box in this chart for config 1 plus F for 10 knot headwind column is showing you 46 degrees Celsius, which we wrote here. 46 degrees Celsius, if we see the weight, okay, weight entry value is 81 tons, which we have written here. Then 81 tons, and the delta weight inside this box is 0.1 tons. Okay, so it becomes inside this box, okay, it is 0.1 ton, so it becomes 81.1 ton. This weight is called as the corrected weight, which we have written here, 81,100 kg. This weight is corresponding to 46 degrees Celsius, but our target is to calculate the weight for 26 degrees Celsius, for which we have to extrapolate now. So in order to extrapolate, first you have to be aware of grad corrections. There are two corrections, grad 1 and grad 2 corrections. Okay, grad corrections are given in kg degree Celsius. Okay, like 50 and 520, which are given at the bottom of this 10 knot headwind column. I hope you are clear what is grad correction. Grad correction is that correction which is applied on the weight whenever you are extrapolating based on the temperature value. Okay, that means you are going to the chart. In that case, the grad correction is applicable. What are the types? We have grad 1 and grad 2. Okay, so now next question is, where do you find grad correction value? The grad correction value for grad 1, grad 2 you can find at the bottom of this column, appropriate wind column, whatever is applicable, okay, as per the case. So in our example, if we have 10 knot headwind column for config 1 plus F, we have gone down and we have seen it is 50 and 520. So these are the grad corrections. So I hope you are aware where do you find the grad corrections. Next, why should you apply grad correction? In order to avoid unnecessary weight penalties. Okay, so you have to extrapolate, and then if you do that, unnecessary weight penalties are avoided, especially due to MEL. If weight penalties are there, if you don't do these corrections, then too much of weight penalties will be there. So that's why in order to avoid the unnecessary weight penalties, you have to apply the grad corrections. Okay, so I hope you are clear why should you apply grad correction. Next is how. Okay, so in order to apply the grad corrections, the procedure is this one. Okay, so there are three ways, okay, in which you can apply the grad correction. The first way or the first case is when the OAT and when the OAT is less than TREF and box temperature is greater than TREF, both correction will apply. if OAT and the box temperature, which is the lowest temperature on the chart, is less than TREF, then only grad 1 is applicable. If OAT and box temperature, that is the lowest temperature on the chart, if it is greater than TREF, then only grad 2 is applicable. How do you apply? In order to apply, just draw a graph so that it can make it more easier for you to draw like this type of graph. Write TREF. Okay, assume it's like something in center. On its left side, if we have OAT, then grad 1. On its right side, we have the lowest temperature, then we have grad 2. So both are applicable in this case. Okay. Next case we have discussed OAT and box temperature less than TREF. So this is the TREF. So if both the values OAT and lowest temperature are on the left side of TREF, then only grad 1 correction will be applicable in that case. Okay. And if both the values lowest temperature and OAT are greater than TREF, then only grad 2 correction will be applicable in that case, like this. So how do you apply the corrections? In case of case number 1, if you want to apply grad 1 correction, just find the difference between these two, okay, and multiply with the correction value, which is 50 in this case. In order to find grad 2, find the difference between the lowest temperature and TREF. So mark here, which is the box temperature and TREF, okay, and here it was OAT and TREF. So after finding out the difference between box temperature and TREF, okay, how much it is right now? 2 degrees. Okay, it's the difference. You multiply it with the grad correction value, which is 520 given the RTW chart. So you will get the grad 2 correction value. So add both these grad corrections to the corrected weight, and then you will get another corrected weight, which is 83,040 kgs. Okay. So in this value, okay, which is the corrected weight for grad corrections, some more corrections are applied, like speed correction, air conditioning correction, anti-ice correction, wet correction. So different type of corrections may be applicable, which we'll study later while we learn about the RTW calculation. Our target right now is to focus on the grad correction. Next case also is like the same as we have discussed. Since only grad 1 is applicable in this scenario where the box temperature and OAT is less than TREF. So what you do is just find the difference between the lowest temperature and OAT, okay, which is 15 in our case, and then multiply it with the grad value, which is 50. Okay, so you get this much value. So you add only grad 1 correction to this whatever weight, corrected weight you would be getting in the in a particular case. Okay. Next, if suppose you are to apply only grad 2 correction, then just find out the difference between these two. Multiply the difference with the grad 2 correction value. Suppose 520 degrees Celsius is the grad 2 correction value, multiply, and then you get grad 2. So now in this case, you have to add only grad 2 correction on the corrected weight. Okay, so that's how it is applicable. So I hope you are clear with all these 3 cases and when is the grad correction applicable. Okay, so friends, I'll come up again with a new topic in my upcoming session. Till then, you enjoy learning this session, and if there are any doubts or any queries, please feel free to drop a comment below. I would appreciate to reply. Okay, so in case I would have missed anything over here in this explanation, please feel free to ask. I'll be replying in the comment section. So thank you and have a nice time.